Okay, so now we are going to be reversing what we did in example 1, but now with example 2. So example 2, we're going to be given some logarithm or exponential equations, and from there, based on transformations we given in the problem, okay, we are going to be able to build our own logarithm or exponential function using the a, b, h, and k values that we learned from the previous example problem. So it says given the equations g of x equals log base 3 of x and h of x equals 4 to the x, write an equation for f of x. Okay, so we have our standard form for our transformations up here so we can reference it as we need it. So part A says f of x reflects g of x over the x-axis, vertically stretches g of x by a factor of 5, and moves the graph right 8 spaces. Okay, so first of all, I need to figure out, am I dealing with my h of x equation or my g of x equation? Okay, because we need to know where our start point is. Is it an exponential? Is it an exponential or is it a logarithm? Okay, so it says f of x reflects g of x. So I know I'm going to be starting from g of x. So I'm going to go ahead and write my g of x so I know that I'm dealing with g of x and not h of x. Okay, so g of x equals log base 3 of x. So this is our parent function, and from here we're going to build upon our equation, okay, based on the transformations that were given in the problem. So the next thing I'm going to do, you guys, is in the problem, I'm going to be labeling if the values of the transformations pertain to an a, b, an h, or a k value in either a log function or an exponential function, which in this case will be the log function. So I'm only going to be focusing on this one right now. Okay, so let's see what the problem states and which transformation it pertains to. So it says f of x reflects g of x, so it's reflecting. Okay, remember when we reflect things, that's usually a negative value, whether it's a reflection over the x or the y-axis. So I know it's a negative sign, so I'm going to keep that in mind. I know this means negative of some sort. And it reflects it over the x-axis. Okay, so I have to think, is this an A, a B, an H, or a K? Well, this is an A value because the reason why I know, remember A values pertain to everything that reflect or move in a vertical motion. So if I reflect in a vertical motion, that is going to be over the x-axis. That's reflecting in a kind of a vertical motion. Okay, so that is our A value, and that tells us it's going to be a negative A value because it's reflecting. Okay, so I know my A value is negative. Okay, also it says vertically stretches g of x by a factor of 5. So this vertical stretch, okay, remember everything vertical pertains to an A value, so I know this is an A value still. Okay, and this tells us what the A value is, the factor of 5. So our A value is going to be 5 here, and since it reflects, it will also be a negative. Okay, so in the A spot, I'm going to go ahead and fill in a negative 5, since I already know that is the start of my problem. So g of x, or now it will be f of x, sorry. We're doing things to the g of x equation. So f of x will be g of x after all the transformations. So I'm going to start with an f of x. Sorry, guys. Okay, so f of x will equal my negative 5 for my a value because the a value is the very first thing you see in your equation. So negative 5. Okay, I'm not going to go any further because I don't know if we're dealing with a b, an h, or a k yet. Okay, it says, and moves the graph right 8 spaces. So let's think. Does the a, the b, the h, or the k value move the graph left or right? Holy hot dog, you guys are so smart. It is the h value. Okay, so since it moves right 8 spaces, this is pertaining to my h value. And remember, we have to think the opposite with the h value. So since we're going right, we're tempted to say the demon cats are going to tell us it's going to be x plus 8. Okay, since it is moving in a positive direction, but in our parenthesis, we're actually going to do x minus 8. So keep that in mind. Okay, so let me just fill those in, and then we'll be done with this problem. So we have log base let's see here, 3, so I have to write C, my bad, you guys. All right, log base 3 of, in our parenthesis, I'm going to write x minus 8. And that'd be it, you guys. That is our equation. That will allow all these transformations to occur when we apply them to g of x. Holy hot dog, wasn't that exciting, you guys? Bam, that one is done so. Okay, let's look at our next problem. Okay, so again, we're going to read about the transformations, and that's going to tell us how to fill out our equation, okay, after we determine if it's a log function or an exponential function. So let's see what happens. Okay, the next one says, f of x reflects h of x over the y-axis, horizontally stretches h of x by a factor of 2, and moves h of x down 6 units. So first of all, we're dealing with an h of x. Okay, it tells us all over the problem. H of x, okay, and h of x. Okay, so I know I'm going to be dealing with h of x, which is right here. I'm going to box it. All right, so I'm dealing with that equation. So that is like my parent function, you guys. That is my start function. Okay, so our start function is h of x equals 4 to the x. Okay, but f of x is going to do all these things to h of x. It's going to move it all around. So we're now moving on to our f of x function. Okay, remember, based on the problem, we're going to be identifying if the values in the problem are a, b, h, or k. And that will kind of tell us where it will go in the problem. Okay, so it says f of x reflects, so that reflect word means negative. Okay, anytime you see reflect, it means negative. Okay, so I'm just going to go ahead and write negative up here so I don't forget. It's going to be a negative. Okay, it reflects it over the y-axis. So this is moving in a horizontal motion. If we look at our axis, if we reflect something over the y-axis, it moves in a horizontal direction. Okay, so the one that pertains to horizontal things is the b value. And since we're dealing with an exponential now, which I know this is an exponential because we have an exponent, since we're dealing with an exponential, the b value is going to go in my exponent. Okay, now we're going to have to be careful with the b value if it's anything other than 1. So we'll address that if we need to. Okay, so my b value currently is a negative. Okay, so we're going to keep that in mind. And it says horizontally stretches. So anything that deals with horizontal stuff, okay, is going to be a b value. So this is also a b value. Okay, so it horizontally stretches h of x by a factor of 2. Okay, so this is a b value. And remember though, the b value, you have to think the opposite. And we find the reciprocal of the b value. So since it's 2 in the problem, my b value, this is secretly like a 2 over 1. Okay, so if I flip 2 over 1, my b value is secretly a 1 over 2. Okay, so my b value is 1 over 2, and this makes it a negative 1/2. Okay, so that is going to be going in the exponent of my problem. Okay, so I'm going to go ahead and start setting that up. Okay, so we have 4. Okay, in my exponent, I know I'm going to have a negative 1/2, so I'm going to set it up. I'm not going to fill anything else out yet, though. Okay, so we're not putting x's in yet, nothing else. Okay, then it says, and moves h of x down 6 units. So that down 6 units. So let's think about it. Which value in my exponential moves things up or down? Holy hot dog, you guys are so smart. It is the k value. Remember k value, kangaroo? Goes up or down. Okay, and you don't think the opposite with the k value. So you do whatever you think it's going to do. So since this bad boy's moving on down 6 units, okay, it's a k value. Okay, and our k value is going to be minus 6 since it's moving down. Okay, so we're only dealing with a b and a k value, so I only need to worry about b in my exponent and k on the very end. Okay, so in this problem, I'm going to kind of zoom out so you guys can see all that. Okay, I'm going to go ahead and throw my x in there because nothing is adding or subtracting to my x. I do not have an h value. So it would be 4 to the negative 1/2 x power, and then on the very end, I'm going to tack on my k value, which we said the k value was a negative 6. Alright, and that's the equation that moves h of x around all over the place according to what that problem states. So bam, this one is donezo.